我是来自Google的工程师，我叫白明。这个时段我非常荣幸的为大家请到来自Google 公司的 Pamela Fox 小姐，她是一直致力于推广 Google 的各种开发技术，把这种开发技术推广给各个开发者，让大家能够更好、更方便的去开发出这些应用程序来。Pamela Fox 她是工作于 Google 的这个开发技术推广部门。主要它的主要的这个推广项目就是 Maps API。那么我们今天的这个题目也是 Maps API 在手机上的一些应用。下面就让大家来欢迎Pamela Fox。
Hey everyone! Alright, so the only Chinese that I remember is Booyao. So I'm going to do it all in English. And I will try to speak slowly as well because I tend to talk really fast as well. Alright, so this talk is about Maps API and mobile devices. So, sorry. Let me turn this off. Alright, so if you were to ask me 2 weeks ago what your options were if you were creating a Maps mashup for mobile devices, this is what I would have told you. So if you're doing Android or iPhone, you could have used one of the native APIs, so MapKit on the iPhone or MapView on the Android. You also could have used the JavaScript API on many of the devices, but it would have been pretty bad experience and pretty slow. And when all else failed, you could use the static maps API, which would simply be an image, and the majority of mobile browsers do support images. So these are your options, and we didn't really like the fact that there were so many different options. And so for one maps mashup, you would have to, make the site that worked for the one that worked for desktop browsers. You would have to make the map that worked for Android, make the map that worked for iPhone. We want to, find a way to make a web API work across all these platforms. Since all of these browsers, these phones today, do actually have embedded browsers on them. So why can't we make it work for them? So there's some trickiness to mobile browsers though, and to making JavaScript APIs work on mobile browsers. So first of all, there's the size of the screen being very small. There's the ways that users interact with mobile phones. So many mobile phones actually have different events. So with the iPhone, we have, pinch, and other phones might have their own ways of doing interaction. There's speed, which is huge. When you're using a mobile device, you're on a slow network, you're on a 3G connection, something like that. So the way things get downloaded to your browser and parsed is completely different and slower. And there's also the reasons that someone would want to use maps in mobile versus when they want to use them on the desktop. So looking specifically at speed, there's a couple things that actually cause the latency, the slowness, when using the JavaScript API in your smartphone browsers. So there's actually all the files you need to download, and it's really bad if you have to load many files because mobile browsers are particularly bad at that. There's also even the time to parse the JavaScript. The Safari iPhone is actually very slow at parsing JavaScript, so there's a significant amount of time spent even after it's downloaded the JavaScript to actually go through and evaluate all of it and to get it into memory. So this is something you have to think about as well. So just backing up a bit, there's actually two types of latency we're looking at. So there's the actual time that it takes for a page to load. So you can see here from Firebug, all the different resources loading into a page, the JavaScript, the CSS, the HTML, the images, all of that, right? Those all add up to a certain amount of time. So that's your actual page load latency, and you want to decrease that. But there's also the user perceived latency. So that's the user who's looking at your site, and when it feels to them like they can use your site. When it feels to them that they can interact with your site. And these are actually different, because you can actually have it seem like your site is usable before you have everything loaded in. So it's good to think about this when trying to make your things faster. So we took our JavaScript API version 2 and we tried to make it faster for mobile phones. The first thing we did is try and reduce the size of the JavaScript. So we try and obfuscate it or compile it as small as possible. If you ever look at our JavaScript, it's really, really ugly because it's all just a bunch of tiny little letters, and we convert every variable into the smallest amount of letters possible so that it can get served in the smallest file. We also tried to modularize code. So when you do like a polyline or a polygon, the code for polyline and polygon isn't actually loaded in until after you construct a poly. But it was hard to modularize code because we tried to modularize it after we'd already written it as one giant file, so it's hard to take it back out and make it something that can be loaded in after. And we also tried to do image spriting, which is a standard technique for reducing latency. So all of the different images you have for your map, so your controls and your markers, you can combine it all into one image and just serve that one image when you pass down the map. So that means you only have one image to download instead of like 10 images. So we tried that, and we got the JavaScript to be a little bit smaller and a little bit faster. And then developers tried to reduce the perceived latency. So a lot of developers started using this trick with the static maps API, where they would load the static maps API first, and then the JavaScript. Let me show you that. So you see this one here. Let's see if it's actually loading right now. So what it actually does is loads in a static map first, and then does the JavaScript after. Looks like the internet has gone down pretty far. All right. So a bunch of developers tried to do this, but this wasn't perfect either. It was a fair amount of code to figure out, and also when you start with a static map, the static map isn't draggable. So if your user happens to get to touch the map before you turn it into a JavaScript map, they would get pretty frustrated because they couldn't actually move the map since it was just one single image. So as much as we tried, we couldn't get the JavaScript API to work well in mobile browsers. We couldn't get it to be fast enough. We couldn't get it small enough. The actual JavaScript is now 190 kilobytes unzipped. There's a lot of different tiles to load in, like 4 tiles there. There was a lot of code that we couldn't modularize. We couldn't take it out of the main code. And we just didn't have things designed for mobile browsers. So we tried a lot of things, and we basically gave up. It was too hard.
好的，大概讲到这里，我先就给大家对上面讲的这些内容做了一个总结，因为今天的这个 talk 整个是用英文来讲，为了方便大家理解，我可能在中间会穿插一些这样的总结。刚才讲到的内容主要就有我们在手机上开发一些地图应用的一些选择，就包括用 static map 呀，还有一些像那个 iPhone 和那个 Android 它们一些 native API， 包括还有在那个 browser 里面用这种 JS API 这样的一些选择。然后我们又讲到一些为什么要用 JS API 在 browser 里面来开发，就是因为手机上做这种地图它有一些困难。首先就是手机上它这个比较慢，包括它的那个 bandwidth， 包括它的带宽会比较慢，在下载地图啊这些会比较慢。还有一个就是它的浏览器的性能也会比我们那个普通那个电脑要慢很多，这是一方面原因。另外还有一些就是它们有不同的这些设备。这些设备在开发起来就会有不同的这种很多的这种要求的格式呀什么的。然后如果说是用那个 JS 在 browser 里面开发呢，就可以让我们来为大家为开发者们来处理一些问题。但是说到用那个 JS 来开发这些地图，它还有一些就刚才说到的像那个 latency， 就是它的读取速度、它下载速度呀，这些处理速度比较慢。我们为了就是解决这个问题，在现有的这个 V2 的 API 里边有一些技术使用到了，包括就是让这个 JS code 尽量的去减小它的这个 size。我们就使用了一些技术，比如说是去混淆和去编译我们的这个 JS 代码，使它尽量的小。另外一些技术包括去压缩图片，去把一些不同的图片整合到一张大的图片里，然后用的时候用那个 CSS 把它切开，然后这样用。但是即使用了这些技术以后，我们这个 V2 的API 就像上面提到的，
在那个手机上应用的时候，开发的时候实力还是不是支持特别好。有些原因呢，就是说我们的它的大小还是挺大的，要下载下来需要190KB。然后还有就是因为在设计的时候我们并没有考虑到这个手机的设备，所以它里面有一些我们就做的不是很好的地方。接下来继续让那个Pamela来讲下边的。
You have a really good memory. Alright, so basically we realized that we couldn't get the JavaScript API to work well on mobile browsers, but we still wanted there to be a JavaScript API that you guys could use on mobile browsers and on desktops so that you could use the same API everywhere. So we decided to start from scratch completely and come up with the JavaScript API version 3. So we announced this last week at Google I/O, and you can get the documentation online, and we have launched it in labs. When we launch an API in labs, that means that we're not ready to commit to its stability yet, so it might change. And we've done this because we want to get feedback from you guys, so we want to see how you use it and see if there's things that we really should change before we make the code be like that forever and ever and ever. So now I'm going to talk about the API version 3. So V3 fixes a lot of the issues that we had from V2. So the initial download size is much smaller. We've gone from 190 kilobytes to 35 kilobytes. It's much faster to actually load a map. And we've actually incorporated that static map trick inside of our code so that we'll do all of that for you, and we'll actually make the static map draggable as well. So even without loading all the tiles, you'll have an interactive map as soon as one image loads. And we've also designed it with mobile devices in mind. So we're constantly testing on mobile devices, seeing how well it works, seeing how the user interaction is, seeing how it works with the small screen sizes. So, I mean, if you've noticed, mobile devices are somewhat the browsers of the future. And I guess, in 5 years, a lot of people will be accessing the internet from their mobile browsers, possibly more than from their desktop browsers. So by treating mobile browsers and desktop browsers as equal citizens, then we should be able to make the best API. So if we compare V2 to V3, here's just a speed comparison. So if we're actually loading the initial JavaScript file, that was 9 seconds in version 2, and it's 2 seconds in version 3. And then to finally get to the point where the map is centered and tiles are loaded in, it was 18 seconds in version 2, and now 7 seconds in version 3. So we've more than halved the amount of time it takes to have a map. So as I was saying, we did the trick where we start with a static map, and we do all of that for you, so you don't have to worry about that. The big thing is that we're using an MVC architecture. This is Model View Controller. So in an MVC architecture, you have models, and they're kind of conceptual models. So you can imagine there's a map, and a map has a lot of properties on it, and you can set the properties, you can get the properties, and you can listen to state change in these properties. And this is all the developer uses to interact with the map. And then there's also the map view, and that's the actual div that creates a map and all the tiles that are inside that, and everything related to the actual DOM rendering of the map. So what happens is that we let you change the model, right? So we let you get and set and listen to changes on the model, and then we do all the view stuff behind the scenes. So the reason this is good is because all we have to do in the initial JavaScript is define the model, and then we can load in the view. We can modularize that view and load that in after the fact. And the view is actually what takes up so much code, right? Because in the JavaScript API, the most of the code is dedicated towards actually creating all those browser DOM elements, right? Especially getting this to work in Safari, IE6, IE8, Android, Chrome. Getting it to work all these places means that you have an incredible amount of code that actually creates, DOM elements and sets CSS properties and stuff like that. So we've managed to separate all of that code so they can always be loaded in after the initial JavaScript. So this MVC architecture is all over the API. So everything in it, map, marker, info windows, they all just have properties that you set and get. We also just cleaned up a lot of code, and we made sure that there were no dependencies between different parts of the API. So if you guys are familiar with version 2, In version 2, you could only ever have one info window open on the map at a time. So there was a dependency there between info window and map, right? Which meant that they had to know about each other, which made it really hard to separate them and really hard to modularize that code. So we removed that dependency. So you can now have multiple info windows. So basically nothing really knows about each other. They just interact after they've all been loaded in. And since this is our, basically our second chance at an API, we can look at a lot of code and say, right, well that was cute, but we really don't need it. So we've been able to remove a lot of code that we had in the original API that just isn't necessary anymore.
这里我再总结一下，刚才就讲到我们现在这个 V3 就 V3的这个版本，是我们最新才推出，然后也现在还是没有完全完成这样的一个版本。它相对 V2 我们就有一些新的改进，主要是针对于之前所说的这个速度上的一些提升。它就做了这样一些事情，它就使得这个我们一开始需要load下来的这个 main.js 的体积比以前缩小了很多。另外就是它在render 这些 tiles 的时候花的时间也会比以前短，这样就可以使得在手机上去开发这样一些应用会快很多。而它具体是怎么来去做这个事情呢？就是怎么做到这个速度提升呢？首先就是它用到我们之前说的那个 static map API 的这样的一个技术，把它融入到我们这个 API 里面。就是你在一开始去用 API 去 load 这个地图的时候，实际我们会先调用 static API 去画这样的一幅图，然后在这个同时呢，我们再把那个其他的这些代码去执行。就是你很快可以先看到一个大体的样子，之后我们再会把它变成动态的。另外引入的一个很关键的这样的一个概念，就是这个 MVC 的这样的一个结构，这样的一个模型。MVC 呢就是分 M 是 model， 就是一个就是相当于是一些数据的这种只是对数据存储这样的一些结构，这样的一些单元。V 是管它的那个 view， 就是它的显示。C 是 controller， 是管它的一些那个逻辑的。这样的话，我们那个主要是把M 给分离出来，比如说是一个 map， 一个那个 marker， 这样的对象呢，我们现在在里边就完全不处理它的一些跟显示相关的，比如说是怎么去创建盗用对象啊，这些都把它分离出来，而只是让它去存储跟它自己状态相关的这样一些量，它只有一些 setter 和 getter。这样的话就可以使一开始的这个 JS 很小，load下来很小，然后你也可以去操作，就是你去编程，去初始化一些 map， 一个 map 几个 marker 这样的东西。在这些创建之后，我们后边会异步的去调用这个 view 的这些逻辑，然后把它画出来，这样就是能提高它的这个速度。最后还有一些就是说是在那个代码内部，我们把以前一些绑定在一起比较那个绑定比较死的这些代码，把它给解开了。比如说刚才那个开麦说到以前的那个 map 和那个 info window， 它其实在实现上是基本是绑在一起的。这样的话就很难把这两个东西拆在两个不同的文件里。而现在我们相当于做了一些重构，把它拆开，这样就可以使那个单独的文件变得很小。
Thank you. All right, so now we're just looking at the hello world here. So here's the actual code. You can see that the map class is inside a namespace, so it's google.maps.map. The namespace is something we did introduce in version 2 about a year ago. So if you want with version 2, you can use it with a namespace. And namespaces are generally a good idea because if you're loading multiple APIs, that way you can avoid a class in one API being named as the same in the class in another API. So in version 3, everything is inside this namespace, and we don't have a gmap class anymore. So here we create a map, we specify a canvas, and then we pass in a bunch of properties. So we're setting the center, the zoom, the map type ID, and then we create a marker, and we set the position and the map for that marker. So when we pass in a map, this will automatically get put on top of the map. You'll notice that a lot of our classes now use object literals for passing in the options. So this is a nice thing to do because it means that our constructors are very flexible. We can continuously add more properties and options to the constructors. And when you want to use them, all you have to do is add them to the object literal. So you'll notice that as a pattern in version 3. And so version 3, we're starting it off with limited features because we want to get your feedback first on just the features that we're starting off with. So we don't want to go and put every feature from V2 into V3 right now and then have the developer community say, but wait a second, we don't like it, it's not very good. You know, we want to put out the limited features that let you do some stuff, but then tweak these and then fix them later. So we can look at some of the examples here. And they're already loaded. So here's just a simple info window example. If you're used to version 2, this will look very similar to version 2. We've kept all of the UI the same, so the UI looks like the same UI as on maps.google.com. The controls are the same. Let's see, reverse. So here's reverse geocoding. So we do have forward and reverse geocoding. Forward geocoding is taking an address, turning it into a latitude longitude. Reverse geocoding is taking a latitude longitude, turning it into an address. So here you can see the latitude longitude I put in, and then I got back an address. I can't read it. You guys probably can. So the good news is that geocoding and reverse geocoding do work well for China. You can also do custom overlays. So besides using markers and info windows, you can create your own overlays, which can be useful. So here, this developer has created an overlay that lets them stretch an image on top of the map and give it a transparency. So this is an image that shows all of the counties of the United States. Here's another example, which is doing a custom info window. So this is a common thing if you want to have a map that matches the UI of the rest of the site. So if you're making a map for a site that's pink and bubbly, then you probably want to have info windows that are pink and bubbly. So you can create a custom overlay and have make the info window look however you want it. So those are the only features we're really coming out with. There's a huge amount more features in version 2, and everyone's asking, is this feature there? When is this feature going to be there? And we are planning on eventually porting most of the version 2 features to version 3, but we may offer a lot of them as open source libraries that you can load in if we don't feel that it belongs in the core library. A few more features. We do, when you specify that you want the default UI, which is on by default, we will automatically change the size of the controls depending on what size your map ends up being. So if your map ends up being really small, we'll change this large control to be a small control. So this is just a nice feature so that you don't have to worry about changing the control size yourself. We don't require keys. I don't know about you guys, but this is really, really exciting for me. Because I've spent the whole, last 2 years of my life getting the wrong key message. So you no longer need to provide keys. We've come up with a different way of doing authentication. So yeah, I see a few people. Yeah, it's good. Yeah. You do have to specify a sensor. This just tells us whether you're using a sensor in your map to locate a user. And this is something that TeleAtlas has required us to ask. But no keys, so you don't have to worry. Your map will just work on every domain, no matter what. We also have completely rehauled our geocoding API. So one of the things we did is we changed the way the address details come back. So before, when you queried for an address, you'd get back this structure with all the address details, breaking the address into different parts, right? The road and the city and the state and the country. But this structure would come up differently every time. It's this really, really complicated XML structure. And if you guys know XML schemas, they're crazy. So we decided just to scrap it and start and do a new one. So this here is simply an array where it starts with the most specific thing. So it starts with the smallest thing, which is a route. And then it goes to a sublocality. There's an administrative area. Then there's a country. And we can specify the long name and the short name for each component. And we can also specify multiple tags to say what kind of type it is. So one of them, this one, CN, this is both, apparently the short name is English, but this is both a country and it's a political type of feature. So hopefully this is a lot easier to parse for people that were actually trying to get back structured address details from our geocoder. We've also added this location type to help indicate what type of geocode it is. So when you geocode, there's a lot of different types of ways that we can geocode. So for one example, how do you pronounce? Cheyenne. Okay, Cheyenne district, which I think is where we are now. The location type here is a geometric center. So what that indicates is that Cheyenne district is actually a polygon, right? And it covers an area. And when you get back to the point, that point just represents the center of that polygon, right? The other example here is One Maid Road, London, UK. So this is a number on a road, and we get back that it's interpolated. So what that means is that you have a road, right? And we know it starts at 1 and it ends at 10. And we know the coordinate for 1, we know the coordinate for 10. So if you tell us 5, we'll tell you it's right here, right? We're just interpolating in this range. So then you know that this may not be as accurate as it could be. The most accurate one is this one. This is actually my old house in Palo Alto, and it's a rooftop geocode. Rooftop geocode means they literally have the exact point location of the rooftop of that house, which is the best geocode you can get. So this can be really useful for figuring out how accurate your geocodes are. All right, we've also given you a bit of bounds information here. So there's two types of bounds. So bounds is just a rectangle with southwest and northeast corners, covers the range. So one of them is the viewport bounds, and that's the optimal viewport that you should zoom to for the user. And that's what we use on maps.google.com when you enter a geocode and we zoom to it. That's the viewport bounds. This other one, bounds, is simply the bounds of that piece of geometric data, right? So if it's Cheyenne district, then it'll be the bounds of that polygon that defines the district. So right now we aren't giving you back the actual polygonal data. The closest we're giving you is the point and the bounds that defines it. Perhaps at some point in the future, we might even give you back polygons, which would be really cool, but not yet. All right, so finally, the whole point of this API was to support mobile browsers. So we used to support desktop browsers. We've now added on that we do support Chrome, since that was a Google browser. We thought it'd be good if we supported it. We also support iPhone Safari officially. And we're working on Android support. It's been a little trickier because Android's not as mature as iPhone Safari yet, but it works decently well. And we may support other mobile devices in the future, depending on whether we're able to get stuff working with that. So on that note, let's just show. Oh yeah, you can go back.
我再把前面这段讲一下总结。这段因为比较长。I can't remember so many things.
Okay, ready? Hello.
首先就讲一下这个 V3 的这个 API 是编程的时候长什么样的。其实跟 V2 现在这段看起来是差不多，只不过在它的那个高导函数里边加了一些 options， 就是直接可以在高导的时候把这些东西传进去。就是说它现在的一些 feature， 它并没有提供全部 V2 的 feature， 而只是提供了一部分。而且它的这个 UI 也是可以定制的，就因为要支持手机，可以选择一些比较小的那种 control。这个是说现在我们不需要那个 API 的 key 的。这个是说我们现在提供的这个 geocoding 就是说我们给一个地址，把那个它对应的这个坐标给它返回出来。这个讲的是就是我们在格式上提供的一些新的一些那个改进，因为其实一个地址有可能它会有不同的那些结果，我们现在可以通过这些 feature tags 把它们都以不同的 type 这样列出来。这个就是讲 location type， 就讲到那个查朝阳区，它可能跟你说这是一个地理的这样，就是一个区块这样一个中心点。你如果查的是一个某一条街的几号，而我们有可能只是估算出来的，就是这种比如说5号，它是拿1号和10号之间里算出来那样点。最后一个是那种精确的点，就是说它是一个屋顶，实际说是最精确的这样一个点。这个时候也可以返回出一个区块。这个就是现在支持的一些那个 browser 了。
Okay. Alright, so here's just an example of the API working on I said, Android isn't quite officially supported yet, but we have been testing on it. So I can go, let me change this to map. My fingers are kind of fat. We know now, like, we've been testing this manually on our team for the last month, so now we know who has the fattest fingers on our team. It's awesome. There we go, hybrid. That's good. So this is just an example that puts a marker, puts a custom overlay on top that shows basically a polygon for a zip code, and that's it. But the point is that it works on a mobile device. You can pan it; it's interactive. See, there's the hybrid labels, and yeah. And when you actually load it in, it'll be quite fast as well. I don't even know that we have any internet right now, so I'm not going to test loading it in. If you have no internet, this will not work. It is not a psychic API. It can't make up the web from memory, but with some amount of Wi-Fi, it loads pretty fast. All right, so since we're China, a few notes on China. So with the JavaScript API version 2, you could load the API from ditu.google.cn, and then you would get some improvements over maps.google.com. So the improvements were more data and differences in the data provider speed, just because the tiles are coming from inside the country versus some random data center. And then also tile alignment. So we have a problem on maps.google.com where satellite and map tiles are not aligned, but we fixed that on ditu.google.cn. Now, unfortunately, you cannot do this for v3 yet. So basically in v3, you're kind of stuck with maps.google.com behavior. We haven't localized v3 at all yet, so this isn't just something, being mean to China users. We haven't done any localization at all, really. So this is certainly something we will look at doing once we've gotten a bit more feedback on the initial. Let me actually just show you what the differences are. So here is China Map v2. So you can see map, satellite, hybrid, all nicely, lots of data and perfectly aligned. And if we go here, it's not, is that Beijing? Yeah, maybe. So we don't have as much data for the tiles, the hybrid overlay. And if we go between map and satellite, they're not aligned. So right now, v3 is not ideal to use for China maps if you want both the satellite view and the roadmap view. If you're simply doing the roadmap view, then it's not a problem. All the roadmap data is there in full glory. But if you want to integrate with satellite, then you should probably wait until we let you load from ditu.google.cn. And terrain doesn't have much either. So simply, we'll consider this a feature request. I'm assuming you guys want it. So I will talk with the team and get it. As for documentation, we haven't localized the docs into any languages yet. We've only been out a week, so it takes a bit more time to translate things. But you guys are welcome to take them and translate them yourselves. I know a Japanese developer is currently translating them into Japanese for other Japanese guys. And there is a China Maps API forum, and I encourage you to use this forum. There's people from the China Maps Google team that monitor the forum and help out. And that's pretty much it.
我再把刚才讲的最后这点给总结。刚才这一点呢，主要是讲的专门对中国的那个地图的用户。因为我们的 V2 的时候，我们一般的那个地图都可以，就是 Maps API 可以从地图点 google.cn 取到的。这样的，它就是可以把我们的这个卫星图片和我们的这个普通的地图去很好的去对齐。这是因为我们有一个问题，它有那个在点 com 上它是对不齐的，但是对于 V3 我们现在还没有，目前为止还没有推出点 cn 的版本，所以这个现在是还没有解决。另外就是到目前为止 V3 的所有的这些 document 还没有，就是这些文档还没有那个本地化，就是还没有中文版这些文档。大家要看的话，只能是看英文版的文档。但是那个以前就是那个 Google Group 对于那个 Function API 的，还是跟以前一样，大家可以从那个里边去对 V3的一些问题进行那个发问，包括就是可以讨论，对不对？
Okay. So now, let me see if I had any more. I would do a few other demos to show. Here's the one that Trapster made. They had an iPhone app, but they really wanted to use a JavaScript API, so they're really happy that this came out. So this is live traffic from their users. So you can imagine this is the kind of thing that is really useful on the mobile phone, because that's when you're driving and that's when you want to know where the traffic is. So this will work fine on the mobile phone, and you can look at it and see where all the traffic is in the United States. I don't think there's any traffic in China. No, you guys are great. There's no traffic. It's all green. Here's another example. So very commonly, one of the other things you could do to reduce the amount of time it takes for the user to get a good experience out of your map is to set the default location of the map to where the user is at that moment, so that they don't have to worry about zooming and panning to where they are. So there's a few different ways of figuring out a user's location right now. This particular example uses Google Gears plugin, and the Gears plugin has a geolocation API that will use any device information it finds, and if it can't find any device information, like on a mobile browser, it will then go and try and geolocate the IP and then give you the result there. So this works in Chrome, it works in Firefox, and it also, anywhere where Gears is installed, it would also work on the Android device. But this does require the Gears plugin. Without the Gears plugin, on Safari iPhone, you can use the geolocation API, which is part of the new HTML specification, and that will tell you the location according to the Safari application. And on other browsers, you could also use client location, which is part of the Google Ajax APIs, and that will tell you the city and state that the user is in, just based on the IP. So there's a lot of different ways to figure out a user's location right now, but if you can do that, then that'll make a much better experience for your user, because it means that they're instantly placed in wherever they are right now. You saw that one. So here's the same thing that we just saw on the phone, but working on the desktop. So you can see all you had to do was write the same code, and it works on Android, it works on iPhone, and it works on the desktop. So this is our ultimate goal, that you don't have to have vastly different code for all these different devices. You can simply write it once, maybe make a few different changes, and have it run everywhere. And that's all I wanted to show you.
下面是那个提问环节，如果大家有什么问题可以提问。大家提问如果是用中文来提问的话，我会尽量尽我的力去把它翻译成英文来，然后跟提出来。
I have a question. It seems that from your slides, I see that the V3 API seems not ready for the Android. My question is, when do you think it will be ready?
Okay.
Thank you.
So yeah, Android is not one of our supported browsers yet. We have been testing on it for the last month, but there were a couple bugs that we haven't been able to get rid of yet. So we want to fix those bugs first, and then we should be able to mark it as supported. The other thing with both Android and iPhone is that Android just had a big upgrade to the Cupcake, which has a bunch of changes in it, and iPhone is upgrading everyone to 3.0, which also has a lot of changes in it. So we have to look at the user stats and figure out how many people are actually getting iPhone 3 and getting Android Cupcake, and then decide if it's good enough to just support those latest versions. Because otherwise, it's actually a fair amount of change in the code, because both of them have changed their browsers quite a bit. So I would expect us to support Android in the next few months or so, and it certainly works pretty well. There's just a few bugs in it.
We heard a lot of exciting features before, but I'm wondering if we want to change a lot of codes on our existing on our existing apps. Do we have to change a lot of codes to upgrade V2 to V3? Then we join us back.
Yeah, so that's interesting. Yeah, we don't really have an upgrade guide per se. So if you're thinking about, so the thing to remember that is this is in labs right now, so we would like you to use it, but I don't know that we want you to use it to like completely replace your V2 quite yet. What we would like is for you to try to use it, and maybe try and make a version of your site that actually works in mobile devices as well, and then to give us feedback. So that in the next few months we can try and solidify the interface and make sure that the interface is exactly what we want, and then get closer towards saying, okay, it's good, you guys should be using this in production websites. So as for upgrading your app, the first thing to look at is what features of the API does your application use, and are these supported by the V3 API? For example, a really obvious one is polylines and polygons are not supported. Directions are not supported. So if you're using either of those, then that's kind of like, yeah, you could actually write your own custom overlay that is a polyline or a polygon, but it's going to take you a lot of effort. So if you're an app that just uses maps, markers, info windows, and geocoding, then that would be a good potential for an app to port over. And we think actually a lot of mobile apps might qualify for this, because a lot of mobile apps tend to be quite simple, because you want to see the location, you want to see where it is on a map, right? But the more sophisticated desktop applications, we're guessing that a lot of them are using features that are not yet in the V3 API yet. So I'm guessing that a lot of desktop apps may not be able to get ported over. So just look at the features first. After that, a lot of the constructors they're similar. There's some changes. If we need to, we'll write an upgrade guide. But I think it's just a matter of little search replace through your code. Yeah.
Other functions you talked about just now, they're not supported or they're not supported yet?
Yet.
Thank you.
Yeah.
How do you handle the authentication without key?
Magic. We are, so the reason so we are keeping track of who's using the APIs. So when you do use the API, we are, tracking in our logs that you have requested the API, just so we know. And if we do need to shut a site down because it's violating the terms of service, then we can just shut it down based on its URL. We don't really have to shut it down based on its key. And we've already done that in the past anyway. So one of the big motivations for having keys is making sure we had ways of taking down sites that were violating us. And we can do that without having to need keys. And the other motivation was making sure people had read the terms of use, because you had to read the terms of use before you can get a key. But legal says that because the terms of use is actually on the map, then it's implied that you've read it. So make sure that you read it, since you don't have to now.
Is offline map viewing here? Is offline map viewing in your radar? If not, is there any obvious reason not to do that, given that HTML5 support database or?
Yeah. Right. So offline. So offline is actually a tricky thing to do with maps, because so HTML5 and Gears, they both have the ability to both store data in a local database and also to store resources in like kind of a local super cache. But both of these are subject to the cross-domain origin policy, which means it's great for storing stuff from your own website, but it gets really tricky if you're a website that's trying to cache resources from another website. And that's kind of the essence of the Maps API, is that you're embedding maps from our domain on your website. So that's one of the big hurdles, is figuring out how to get around the problem of the cross-domain policy. And besides that, there's also the problem just of working with our data providers to make sure they're okay with that. But I think actually our recent terms of use change last year is more permissive towards caching, and does say that it is allowed to cache for performance reasons. So if we could get over the technical hurdles with the cross-domain issues, then I could see us enabling caching of the tiles and the resources in the future. For now, for your own maps, you could cache stuff like the geocode results, right? You could cache things like your own custom maps. This guy here with the zip codes, he caches all of his zip code maps locally, because sometimes he just doesn't even use our base maps at all. And that's fine, because those are all on his server, so he's able to do that. So there are a few things that you can take offline right now, but there's still technical hurdles towards getting the entire map thing offline.
I have a question. How to get the location of the user more actually.
He means how to get the user's location accurately.
Accurately? Most of the techniques that I mentioned won't give you the user's location to the exact place because of privacy reasons, and also because of accuracy reasons. So any of the IP-based approaches will give you very general, like city, state, country, because IPs aren't that accurate, and also for privacy reasons. The gears geolocation does get you more precise, but I don't remember how precise. It would depend on the accuracy of the actual attached GPS device. Besides that, you could also, there's a couple other things I didn't mention. So there's various services out there that people use to store their location now. There's Fire Eagle, created by Yahoo, and some people store their location there. There's Skyhook or Loki. There's Google Latitude, or Google, you can use it to see your friends, and it works on phones and in iGoogle. And you can get KML feeds and JSON feeds for users' location that way. So honestly, there's a lot of different ways right now. For the most accurate location, I would probably use Gears for the Android, and I would use the Safari geolocation for the iPhone. I think native apps can also get the location via a native API, but you'd have to somehow pass that into a browser control, and that might be more accurate as well. I don't think it's solved yet. I think in a year, hopefully we'll have a more cohesive way of getting user location. Right now, there's just a lot of wrapper libraries out there that will use 5 different techniques to hopefully get back a location.
There are some ways to locate a user, by there are some ways to locate a user, with a PC, without GPS.
Yeah, so for PCs, that's when you want to use the IP techniques, the ones that use IP address, since that's really all you know. Is that not what you want?
If a user selects to internet by proxy.
Oh yeah. Yeah, you guys do that a lot here, huh? So if you're doing by proxy, the whole IP method doesn't work. It actually doesn't work inside Google because we all use a proxy as well. So at that point, I would probably look at something like Latitude or Fire Eagle, but you'd have to have the user give you their credentials for that service. So if you wanted to use Google Latitude, then you could ask the user, okay, publish your location and then tell me your username. And then you could always show that. With Fire Eagle, you can have the user say, yes, I give this application permission to use my Fire Eagle location. and then they can give you it that way. So there you'd have to use what's called the location brokering services, these third parties that collect the user's location and then give it back to you.
还有这个问题。
我就用中文问一个问题就比较简单一点，就是说，做 GPS 导航的时候的话，因为我们这个地图是有偏移的，我不知道就是说我们在定到一个点以后，我们想做这个自动的偏移纠正，就是我想这个点肯定在路上，它可能会本来应该是在路上的，可能它恰好在房子边上，那么我想把这个点自动的纠正到这个路线上面来的话，就这种就是说，偏移纠正的算法吧，这个脚本方面有没有这种类似的东西？
His question is, when doing the GPS navigation, since there's some locations are not aligned to roads, is there any method to align them back?
Is it in D2 or in Maps?
是地图点过点 cn 呢，还是well, I think this question is hard to translate, but comparatively it's easy to answer, so I will answer it direct. 我觉得这个在地图点 cn 上，其实现在基本上已经是没有偏移的，所以就是如果是你使用地图点 cn 的这个 API 或者是直接地图来做的话，就是我觉得是可以直接做的，因为那个偏移现在只出现在.com 那个上面。地图点入。他的问题是，his question is, no matter what products you use, if there are some misaligned locations, how could resolve it?
Yeah, so there are some areas where the data isn't correct. So in that case, like the things don't maybe align, maybe up to I think 30 feet or 30 meters. So we do have a tool for reporting it. So I would start by reporting it here. It could be a general problem, or it could be a problem with just that location. So you can go and find the location and report the actual the misalignment error. And this probably relates to either our satellite imagery or our vector data is off.
就是说，这个如果是我们Google 的地图上的数据的一些偏移或者是位置不准的话，你可以进行那个报告。但是如果是说你在用其他一些数据做 GPS 的时候，这个我们现在可能就起码在这个会场上，我们现在没有办法做一些解答，怎么样去把它偏移回去。谢谢。
Hello, Camila. I have a question. I know just now compared with the version 2 and the version 3, I do see a lot of improvement in performance. It will be very, very beneficial to the mobile device. I think the version 3 should be the next version of the GMN on Android, right? so I'm not sure. I don't know how many bugs or how serious problems with version 3, but I just confirm with you. Can we develop the Android applications based on version 3 API? And even though it's a little bit bug, but we don't care. But I don't want to understand how serious is that.
We certainly want you to make make applications work on Android. The main bug is when you drag the map, you'll sometimes get a view save image dialog, and so that's the one we're working with because that's a really annoying dialog. But that's really one of the main ones that I can think of right now. But certainly start developing on Android, and I think it's a good idea that if our API is so good that Google Maps Mobile should just get rid of their product and just use ours instead. The fix for the problem would be, we'll be rolling out new versions of this every week or 2 weeks. So hopefully the Android bugs will be fixed in the next couple versions.
I mean, you fixed on the Android platform or just fixed by a service end?
So we're trying to make the fix on our side, but we are working with the Android engineers as well.
Okay, we can keep the cupcake or...
Yeah. So we'll try and make it work with the cupcake build.
Okay, thank you.
还有问题吗？如果没有问题的话，我们就再一次掌声感谢他们。